AnchorSave is a small, focused saving system. It is designed to be reused across projects without relying on automatic serialization or hidden behavior. It is MIT licensed, fully open source, and hosted as a UPM repository on GitHub. Saves are written as plain JSON files. The system is slot based, and saving is explicit, meaning nothing is saved unless a component chooses to participate via an ISaveable interface. This is intended to be readable, debuggable, and reusable across projects. Installation is done through the UPM using the GitHub package manager. You copy the link. You also need to make sure that Git is installed for your PC for it to work. I have installed mine for Linux here. It works on Windows as well. And in the package manager, you can click on this button and install package from Git URL. You paste the link and hit install. This package ideally targets Unity 6 and declares Unity input system as dependency for one of the samples. A demo scene is included, and I am going to use that for the rest of the video. The demo scene is intentionally simple. There's a player that can move, collect coins, and a UI counter that shows how many coins you have collected. I'll collect a few coins and press F5 to save. The game has been saved to a JSON file here. Now I'll exit play mode, play the game again, and this time I'm going to go over here and press F6 to load my previous game. And you can see that the player position and the player count has been successfully loaded. There's no hidden logic here. The saved state comes entirely from the components that explicitly opted in. The core concept in this AnchorSave saving system is the ISaveable interface. Any component that wants to save data implements this interface. In the demo, the player implements the ISaveable interface and defines a small struct called PlayerSaveData. This struct should only contain the data that I care about, or in other words, the data I want to save. In this case, position matters, and in my coin manager save data, the collected count of the coins. The interface exposes three things. First is a unique ID called player. This is something that you give custom. For objects that are duplicated, you can add a persistent ID script, which will generate a new GUID, which is unique to every object. And then instead of hard coding a UID, you can get the component of persistent ID and use the field ID. If I go to the directory of my save file in the console and open the save file with a text editor, you will be able to see the UIDs of the player and also a randomly generated GUID for each coin in the game, and it stores whether it is collected or not. The interface also exposes a capture state function and a restore state function used for saving and loading. Nothing is discovered automatically. In capture state, we return a new player save data and we assign the position to be the current position of the game object. Remember, vector 3s and quaternions are not serializable by Unity, so you need to either create a float array or use 3 floats as a substitute. You need to make sure that these structs are serializable, and on restore state, you simply get that player save data back by using the JSON utility.fromJSON function, and we pass in a player save data and we convert the state into a string. And then we set back the position of the player, in this case, back to a new vector 3 and the 3 XYZ coordinates stored in the first 3 elements of this array. And just before I set the position, I disabled the controller and enabled the controller just to avoid bugs. But the saving and loading is handled by the SaveManager. You have 2 simple buttons that you can work with in the editor while you're in play mode. If you're not in play mode, it will be disabled. This is done so that people don't accidentally save during edit mode. The manager needs a reference to the saving system, which you can drag and drop it here, or it will find it when you play the game automatically. If you don't have a save manager in the scene, you can go to Window, Saving System, and Initialize, and it will create a save manager and a saving system for you. Just make sure to drag the saving system in case you want this in a separate object. The manager supports 4 save modes. Simple as manual save and load using a single save slot. Autosave only automatically saves at fixed intervals to a fixed slot, which is the autosave slot here. Slots allow manual selection between multiple save slots. Each save slot can have its own unique save file name, a save game name, which is just for display purposes, and you can also specify whether this save file can be deleted or not. All of the code for deleting save files is also included. Autosave with slots combine both autosave and slots, where you can specify a single slot to only have autosave in it. The manager always keeps track of a current slot number, and there must always be at least one slot available. For autosaving, you need to add a new component called Autosaver, and it will contain only a single field called save interval, and it will save at every 600 seconds. Autosaving is intentionally separated so that it's optional and explicit. You can also configure the file extension for your saves. By default, it is JSON. You can save it to SAV or anything that you want. It does not matter. Finally, the manager exposes unit events for save and load, including success and failure events, which are meant for UI and feedback and not core game logic. It is important to be clear about what this system does not try to solve. Save files are plain JSON, and these can be edited by the player. There is no encryption and no cheating prevention. This system assumes the player owns their own save files. There is also no multiplayer support, no server authority, meaning co-op games that are server-based, co-op games that are more client-based, where saving happens only on a single PC would work fine. And there's also no automatic scene-wide serialization. Everything is manual by design. Just because cheating can happen doesn't mean that it's bad for your game, especially if you're indie. If you are a AAA studio, you may want to look into a better saving system. But if you are an indie team, it's better to have a saving system which allows players to cheat. And this allows them to customize or tailor our game to their needs. This also allows modders to pour their craft into our game, which is actually beneficial for our game, and it improves the marketing scope and the playability completely. So I recommend letting the players cheat. It is okay. So AnchorSave makes sense for small to medium scope projects where you want control and clarity. As you can see, it is easy to debug where things go wrong with the saving system. If you were to save to a binary file, this wouldn't be the case. It's also useful if you want a reusable base that you can modify and extend. You can go to the packages and AnchorSave folder to go to all of the runtime files, and you can tweak these code to your liking. It does not make sense for competitive multiplayer games or security sensitive projects. Okay, the full source is available on GitHub under the MIT license. You are encouraged to read it, modify it, and even use it as a base for your own systems. In the next video, I'll break down how this system was designed from scratch, and we'll make the system again together so that people who find it difficult to understand how a saving system works will be able to understand it. This will include the way we design structs, interfaces, and the trade-offs between them. The next video is going to be an hour long or something, where we design a complete saving system from scratch. Cool. I'll see you in the next one if you are interested. Subscribe if you want to get to know the updates for this package and also learn some cool Unity stuff. So yeah, take care. See ya. Love ya. Bye bye.